Good morning, Mr. and Mrs. Adams.
Good morning.
Good morning.
Thanks once more for agreeing to meet and consider allowing us to conduct the seismic survey on your property. Based on our phone call the other day, you had some questions and concerns. We respect your concerns and desire to safeguard and protect your land. I'm confident that we can address your questions in order to work together successfully.
Thank you for taking the time to meet with us. We were just unclear why you want to do seismic testing and why it has to be done here. I've seen what I assume to be seismic testing being done nearby, so I'm confused. Why do you need to do it again?
Right, can't you just use what you already have?
Those are good questions. Our overall goal is to generate a 3D image of the rock layers below the ground. If you take a look here, you will see that the layers deep below the ground are much like they are at the surface. They have hills and valleys, ups and downs, flat spots, just like you see up here. If you look at a rock cut where a highway goes through a hill, you can see the rock layers are not flat. The image that we obtain is then used by geologists and geophysicists to interpret where the best locations are for horizontal drilling. Based on the interpretation, seismic data will allow oil and gas companies to fine-tune their drilling efforts, making them safer, more efficient, and enables them to get the maximum possible results from their wells. The data that we obtain through the seismic survey shows them where the rock layers are beneath the ground. Before drilling a well, especially a horizontal well, the oil or gas company needs to know how deep the target rock layer is, so they know how far down they need to drill, how thick that layer is, and where it goes up and down. This knowledge is especially important when drilling horizontal wells. They need to know where fault lines go through the rock layers so they can avoid that area when fracking. You probably saw a 2D seismic previously. Sometimes these are conducted in advance of the 3D seismic. This 2D seismic only produces a small strip of data along the roads. This doesn't provide all the data that we would like to have. Providing this information to the oil and gas companies helps to ensure that production from the well is maximized, but even more importantly, greater knowledge of the subsurface environment can lead to safer drilling and completion operations.
Okay, well, it sounds like all of this is a good deal for the oil and gas company, but where do we stand to benefit from this?
The more landowners that allow us to conduct seismic on their property, the more complete of a picture we have, ultimately leading to both safer operations and increased production of oil and gas.
As a mineral owner, I like the idea of potentially increased royalties, and improved safety is always positive. But how much of this disturbance are we going to experience for this benefit?
Will we have a say on what's done on our land, and how do we know if you're going to address these concerns?
As a permit agent, it's my job to address your concerns, offer solutions, and walk you through this process. I'll gather all pertinent information that will be documented and relayed to crew members to ensure proper procedures are followed and that we comply with other permit requirements. Take a look here to learn a little bit more about the process. After permitting, a survey crew will arrive to mark access and points with pin flags, flagging, and wooden stakes. Men with GPS packs will conduct this process on foot and conduct a hazard survey of your land. Survey crew personnel and your permit agent may ask for directions or assistance with access. This will aid in communications between you and us. We will take the path of least resistance when crossing your land unless otherwise specified by you. Once this is done, survey operations are complete and permits will be finalized. At this point, we move on to the next phase, which involves laying out the receiver lines and placing the charges. If there is significant ground cover in the areas where we will need to put equipment, crews will clear this vegetation, but they will not move mature trees or construct new access roads. Crews will also mark source lines to indicate placement of charges or vehicles, and receiver lines to mark points where recording equipment will be placed to take readings. The recording equipment will arrive by truck or by helicopter, and you will notice crews on the ground placing this equipment on properties near the seismic survey and later returning to remove them. As you can tell, all of this work involves a high level of logistics to safely coordinate the movement of all the men and equipment.
Now, you had mentioned that explosives are being used. Isn't that dangerous?
There are risks involved with any activity. Following proper procedures and safety protocols minimizes risk. If you look here, no activity will take place until all required permissions and permits are in place and compliant with all local, state, and federal safety regulation. Any individuals involved in handling, supervision, or detonation are required to have a blaster license. As you can tell, there are numerous regulations and controls to ensure safe handling and use. You will see that limits are set on the proximity of shot holes to private structures, and in advance of drilling, a one-call notice is made to verify that any holes drilled will not interfere with existing infrastructure. Once the hole is drilled, a shot will be lowered into the hole. Each shot will have 2 electric detonators attached that are digitally encrypted and require a special blasting box to prevent unintended detonations. Once the shots are installed, there is continuous roving security to monitor the various points. Before the project can be completed, the DEP requires that all shot holes have been detonated and accounted for.
Will there also be trucks driving through my property?
Wherever possible, units that create the seismic waves will operate along existing roads or trails, reducing the impact on surface lands or crops. If crews or vehicles do need access to private property, this will be coordinated with you, the surface owner, in advance. As you will see here, the trucks will travel along the road or trail, stopping periodically to lower the vibratory plate that produces the acoustic wave. While you will certainly notice the vehicles, what you hear and feel will be minimal when equipment directs the seismic waves into the ground. At this point, as you will see here, the recording crew already laid out the monitoring devices and cables. Once the equipment along the surveyed lines have been linked, the whole network connects together in a grid-like pattern. The network was developed using the hazard survey that you completed. At this point, recording can begin. Shot holes are sequentially detonated and the data is recorded. The waves that are created by the charges and trucks are reflected by subsurface formations and returned to the surface where it is recorded by receivers called geophones, similar to microphones. Only after all of this has been completed can geologists and geophysicists start reviewing the data.
Thank you so much for taking the time to explain seismic testing to us.
We now have a much better understanding of the process and the need to collect this data, and we are happy to let you do testing on our land.
Thank you. I just have some paperwork for you to sign.
Thank you.
Thank you.